Hi, it's Graham Cox here, co-founder of OptiSurface, and in this video I'm going to give you a quick demonstration on how to use exclusion zones to cut through a ridge. Okay, this is the finished result, but I'll do this from scratch. And basically what we've got is this pink rectangle here is an exclusion zone, and the black lines are break lines with a flat base batted up to the design. Now, what we're trying to do is drain this depression here out through this low spot over here. Now, if we let OptiSurface, if we don't have an exclusion zone there and we just let OptiSurface find its best path to cut water through here, we will end up with a result like this. So I've just turned off that exclusion zone and recalculated, and you can see here it has cut a path through there, which isn't too bad, but it is broader than we want. We want to have a more defined drain through that ridge. So what we do is we draw our rectangle in place. We can do that by draw new zone, subzone, click where we want it. I'm just using this as a guide because I know exactly that's where it has to be. We're going to tick this into exclusion. It turns pink here. And what that means is if it's going to exclude that area from the OptiSurface calculations. Now the critical thing is if we just turn on these points, so the grid points that make up the proposed topography, you will see, let's just make this to make it a bit more obvious. So you can see these blue points are where OptiSurface calculates elevation. And what we've done here is we've drawn that exclusion zone perfectly covering one of these rows. Now if you make that exclusion zone too thin and don't cover enough points, it'll not, basically won't work. And let's calculate again. So we're going to calculate on the boundary, which this will take a few minutes, so I'll pause the video and come back. Okay, here's the results that we've got back from the calculation. You see there's no blue points inside that exclusion zone. So the exclusion zone is effectively acting like a internal boundary. So it's saying just ignore this area within this exclusion zone. We'll take care of it. So if we look here, what it's done is it's drained all this area to the exclusion zone. The reason why there's a surface in there is that it's triangulating from that point across to this point, which you can see here. So if I turn on the triangles, you can see how it's triangulating straight across there, and that's why that area is covered, even though it's an exclusion zone. Okay, so now we know the water will drain from here into here. I just update you. See this red zone? That is a ridge zone. That's a ridge zone. That tells OptiSurface when it calculates that's a high point and you can't let water go out there. Because if we didn't have that ridge zone, it would just push this water, it would just slope this land out here to push water out here. But we couldn't push water out here. There's actually a house here. We didn't want to push water here. We have to take it north. So by putting that ridge zone, we've said, okay, force that water back this way. Okay, so it's sloping to this exclusion zone. Now we need to manually cut through this ridge using the break lines. So that's where we can draw a break line using this tool here. So I'm going to do from here to here. I'm going to double click to finish, and when I clicked first point it was there, when I clicked the second point it was there, and it's picked the proposed topography at that point to define those 2 points. So it's sloping at about 0.1% there to get that at this end. Okay, now I'm going to batter this break line to the surface. So I'm going to go here, right click batter. I'm going to offset it 3 meters each way. So that means there's going to be a flat bottom on the drain of 6 meters total, 3 meters each way from the center line. And then I'm going to batter it up at 10. I'm going to go both sides of the center line, so left and right, and I'm going to batter up to the proposed surface. And I'm going to triangulate without the break lines for the calculation. This means that it'll ignore this break line and won't triangulate it in when it calculates. That's important so it can shoot the batter lines and hit the proposed surface. If I already had some break lines there, this means it would update those existing break lines that have been created, off each side of it, and then delete points inside the batter. So any of these blue points, these blue grid points that are inside the batters, we need to get rid of them because we don't want them messing up the batters. So I'll click OK. And there we go. So, a bit hard to see. Let me just turn off the blue points. Markers off. Okay, so you can see that we've got our center line. It's offset that center line 3 meters each way to give us a flat base, and then it's batted up this break line to the proposed surface at 1 in 10. So that slope is 1 in 10 there, 10%. And now you can see that water will drain out. Looks a bit high there. Yeah, see how that's shot down? So we've potentially got this end a bit high. I'm just going to check that again. So I'm just going to triangulate the surface without these break lines. So if I tick that, if you see the triangulate proposed topography without break lines. So that means that these lines are no longer affecting this surface. So the benefit of that is that I can click on this line now and see, okay, this is the proposed topography, this purple area. This is the proposed topography without the break line included. And you can see, yeah, I've got this too high here. I actually need to bring this out here a bit. So I'm just going to edit this break line. I'm going to drag it out here to this low point. Actually didn't have to stop editing there. So now it looks like I'm at the low point of this proposed topography, but I'm going to have to lower this. So I'm going to edit this break line again. I can just lower that down to here. Now I'm going to have to lower this end down. I can keep dragging that down. Another thing I can do is just go into here, edit points table, put in 0.05% slope in there. So that means that's the slope from the point upstream, and it'll calculate the elevation required. So you can see that there now is that break line now is sloping at 0.05% this way. Okay, so if I stop editing that break line, and now I have to update these lines again, I have to recalculate them. Let me check this is low enough over here. Be quite a bit lower. Yeah, it's gonna have to. Yeah, I think we're gonna have to extend this out actually. Edit. We're gonna have to go out here until we get above, till we get to daylight. So now it's at daylight there. And daylight there, and if we go back to the table, this would have changed a bit because we've made the line a bit longer. But again, stop editing. Okay, so now we have drag the right mouse pointer, it zooms out, or actually you can do zoom both axes. Okay, so that looks to be working. Let's close this and re-batter this. If we go batter, these are set properly, both. We click calculate, it'll remove the existing brake lines that were on the outside and reshoot them. And that's what they look like. Now, to get that to tie back into the surface, we've got to re-triangulate with those brake lines. You can see it's triangulated in now, and in 3D you'd normally see that in 3D. It would look more pronounced, but for some reason there was a problem with the data when it came in, and must have had a high point in it or something, and the vertical exaggeration factor is very low, so you can't really see it once you go into 3D. But anyway, that's how it works. If we turn the design zones back on, you can see that we've had to go a bit further. If we look at the cut fill map, you'll see that it doesn't reflect that drain that we've dug through there. It's showing zero cut fill, that green zone through there. So to update that, what we need to do is recalculate cut fill on a grid that, and you can rebalance it, which means it'll adjust the elevations it'll adjust the earthworks to balance the earthworks. I'm just going to tick that off for now. Okay, now if we look in there, we can see that now it's cutting through that ridge. There's still a little bit of cut here, but that's from the original design. And it's exiting there. You can see we've done that for a couple other locations to get the water through where we wanted it to go in the same fashion. Okay, I hope that's useful. If you've got any questions or thoughts, send us an email to support@optisurface.com or give us a call.